Okay, so hopefully the first week's worksheet that you did on system schema and free body diagrams went well and you understand all of the solutions that I gave. Today I want to start adding some, not necessarily refinements, but some additional knowledge. So what I did is in your huge packet on page 2.5, there is this diagram at the top, and I want to talk about it in a little detail, and I specifically want to try to explain something that is in this box. So the first line says, points or surfaces of contact between touching objects are interaction points or surfaces, and so we know we're always going to have a contact interaction there. Then it says at each point, one object exerts a force on the other, and the other exerts an equal magnitude, oppositely directed force on the first. And then that is actually Newton's third law. You may have heard to every action there is an equal and opposite reaction. Horrible wording, but basically that's what it is right here. We will improve that wording eventually. And then we want to use this menu of forces for the intersection points and surfaces to construct the free body diagram. And that menu, again, just to remind you, is back here. If you're trying to figure out how to label forces, right now I'm not so concerned about the label, but if you're trying to, here's the menu. And next week we're going to start looking in those in more detail so that you can feel more comfortable filling them in. So anyway, what I did was I just took a snapshot of this first part up here and I put it down here, and we're going to do a schema and talk about why do I draw a boundary or what's happening. So if we read it, we are to construct a free body diagram and a force diagram for the person, and for each block shown at the right, the blocks have frictionless gliders. So as we look at the block, or at this diagram, we know that we're going to have friction here, and then these have no friction. And so the first thing that we're going to do is a schema. So we have the person. We have block 1. I'm going to say B1. If you want to abbreviate these, as long as it's really obvious, that's fine. B2. We have surface. I'm just going to call it a floor. And then we also have the earth. So we know that the earth is interacting with everything, and this is called weight. And we know that the person has friction with the floor, so I'm going to put that in. I'm going to say this is friction. And then the person has another interaction with the floor. The floor is holding the person up, and this is what we call the perpendicular force. And so we also have the floor is holding the block up, and it's holding this block up as well. So our diagram gets really messy pretty quickly. Now, there's something else happening. We know that the person is touching block 1, and block 1 is touching block 2. Well, those are also perpendicular forces. They are just going sideways. Okay, so perpendicular force just means perpendicular to the contact. So we have 1, or the person is touching 1, but we have 1 touching the person. And we also know that 1 is touching 2 and 2 is touching 1. Those are what we call the perpendicular force. I'm actually going to explain it in more detail next week. So these are all of the interactions between the blocks, the person, and the floor. Now, we want to talk about this sentence here. At each point, one object exerts a force on the other, and the other exerts an equal magnitude, oppositely directed force on the first. And that is exemplified, or this is why we draw a line between two objects that are touching each other, or in the case of the earth, two objects that are interacting with each other. So I'm going to write this out. So we know that person is pushing the block, or block 1, And this is equal to block 1 pushing the person. So this is something called Newton's third law, which again we will discuss in more detail, but I wanted to introduce it. So that is why this interaction between the two objects is equal and opposite. So that leads us to something that you're going to think, no way, this is not possible. So we're going to look at the interaction between the earth and the person. And we know that the earth pulls the person. This is actually what we call weight. The pull of the earth is our weight. But because this line goes from the person to the earth and it is not broken anywhere, this equals the person pulls on the earth. So the earth pulls on us, and it's equal to the pull we have on the earth. That is Newton's third law. Again, we'll talk about it more. Okay, now the last thing we want to do is identify which object do we want to do a free body diagram for, because we have 3 basic objects. We could do the person, we could do block 1, we could do block 2. So I'm going to do block 2. So I'm going to draw a boundary around block 2, and I see that there are 3 forces interacting, or there are 3 interactions with block 2. So I'm going to do my dot. Oh, let me do it in blue. The dot, this is block 2. We know that the earth is pulling down, and that is the weight of block 2. Now, we need to think about equilibrium. So we're going to ask the question, I'm going to do it in this green color. Is block 2 in equilibrium? And so we have to ask, is it moving in the vertical direction? So moving in vertical, and we're going to say no. So that means we have equilibrium in vertical. And so that means that the perpendicular force from the floor, this force right here, has to be equal to the weight. So we've got perpendicular, and we can again just say this is the perpendicular on block 2. I've got a pair of forces that are equal, and they are looking like that. Okay, now I only have one more force, and this is the push or the perpendicular force. It's a push. Block 1 is pushing block 2 forward. So this is the perpendicular force on block 2, and we can say by block 1. When we see 3 forces like this, we know without question there's no equilibrium in the horizontal direction. Okay, so in the horizontal direction, I've got a changing velocity. And in the vertical direction, I've got no motion, so I'm in equilibrium.